Hello everyone. Let's study about electric field and force. Here the definition of electric field is it is the free space around the charge where the force can be experienced. In order to find the strength and direction of electric field, we use the term electric field intensity, which measures how strong the field is. And the mathematically, the formula of electric field is force in the field of given charge, that is source charge here, like positive source charge, and this small is positive is the test charge. Test charge will always be positive. Now this test charge will move away. If the source charge is negative, the test charge will move towards the source charge like this, which shows the direction of electric field. So the strength of electric field is force on the test charge, and the unit is Newton per Coulomb, and the direction is from positive to negative. Like if two positive and negative source charges are placed in this way, the positive test charge will move from positive to negative, which gives the direction of electric field. Now this direction of electric field is depicted by electric field lines, which shows the direction of electric field at a given point, and tangent to the electric field line gives the direction of electric field. And these lines never intersect because the point of intersection gives two direction of electric field, which is not possible. And these lines are always perpendicular to the surface of the conductor. Now the visual representation is shown here. For the single positive charge, electric field lines will be outwards because in the field of positive source charge, Q naught, which is always positive, will move outwards, as shown with the help of a prototype model. Here, positive source charge is moving towards the test charge. The test charge is moving away, which is positive. That is why electric field lines due to a positive charge are outwards, and for the negative source charge the electric field lines are inward. Here again in the prototype model, when the negative source charge is moving towards q naught, which is positive, it attracts. So the field lines due to negative source charge will be inwards, which shows the direction of movement of q naught. Similarly, when a dipole is there, the field lines from positive to negative, and between the charges the field will be stronger as compared to the outer area. Here if two charges are same, then we will get the neutral point between the charges where electric field will be weakest, that is 0, as shown. This is in this model, when there is a dipole the field lines will move from positive to negative, and for two similar charges they will be repelled and will move away from each other like this. Now, for uniform electric field, the spacing between the lines, electric field lines will be same, and for non-uniform, the spacing will not same. For stronger field, they will be closer, as shown in the figure. Next, in order to understand this formula, Coulomb law is introduced, which states that the force between two charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of distance between them, as shown. In the first case, both the charges are placed in vacuum, like there is no medium between them. Then the formula will be small k q1 q2 by r square, where small k is a constant of proportionality And if the medium is introduced between two charges like water, then the formula will become 1 by 4 pi epsilon naught, and one new term, capital K or epsilon R, is multiplied with that epsilon naught. That epsilon naught and epsilon R makes a term epsilon M, where epsilon R is dielectric constant and having two different formulas as shown. Now this epsilon R plays important role as explained in this example, that when NaCl is placed in vacuum, let the force between them is 81 Newton, and when same NaCl will be placed in water, the force will be 1 Newton, because dielectric constant of water is 81, which is a constant quantity. In this way, water can be a universal solvent as shown in the example. Now, what is the meaning of this epsilon naught and the dielectric constant? It gives us the value by which the force between two charges be decreased when the given two charges be placed in a certain medium, and the formulas are shown here. Epsilon r or capital K is the constant of for every material. Now there is a vector form of the Coulomb's law, where there are two position vectors r1 and r2 vectors for charges q1 and q2. Both the charges are positive here, so the force on q1 due to q2 is F12, and the direction of this force is from 2 to 1 outward, and on q2, that is F21, the direction will be from 1 to 2, R12 cap. These are the unit vectors, 21 cap and 12 cap. Both are opposite vectors. That is why they are related with each other with the negative sign, because of the opposite directions. If we will put this value here, we will get F12 vector equals to minus F21 vector, which shows Coulomb's law follows the third law. Thank you.